Hi friends, welcome back. In the last lecture, we have completed topic number 1, linear differential equation. Okay, first recall what we have done in that topic. We have seen how to find a solution of linear differential equation with constant coefficient. Its solution is given by complementary function plus particular integral. There are 4 cases related to the complementary function. Case number 1, if roots are real and distinct. Then case number 2, if roots are real and repeated. Case number 3, if roots are imaginary and roots are distinct. Case number 4, roots are imaginary and repeated. At that time, how to find a complementary function we have seen. Also, we have seen type 1 to type 5. This type is related to for finding a particular integral. In type number 1, we have seen how to find particular integral when right hand side is of the form e raised to x or e raised to minus x. In type number 2, we have seen when right hand side is of the form sin x or cos x. In type number 3, right hand side is of the form x raised to m in its positive integer or any polynomial. Type number 4 is of the form x e raised to x into v, where v is a function of x only. In a type number 5, right hand side is of the form x into v, where v is a function of x only. We have seen how to find particular integral. And lastly, we have seen when right hand side does not belongs to any one of the above forms, that time how to find solution. In this lecture we have to see some multiple choice question based on this topic. We will see here in this PDF. In this lecture we have given question with 4 option and also solution I have given. Here we will discuss how to find solution of this multiple choice question, how to select correct answer among 4 options. Let us start multiple choice. Question number 1, first question. If the differential equation dny upon dx raised to n plus p1 dn minus 1y upon dx raised to n minus 1 plus and so on plus p and y is equal to capital X is a linear differential equation with constant coefficient, then RHS is a first option is constant, second option is a function of x, third option is function of y, fourth option is a function of x and y. Answer is also given. See, as start of linear differential equation, we have seen the general form of linear differential equation with constant coefficient can be written as dny upon dx raised to n plus p1 d raised to n minus 1y upon dx raised to n minus 1 plus and so on p and y is equal to capital X, where p1 p2 up to pn all are constant. Remember thing is that p1 p2 up to pn all are constants, and right hand side nothing but capital X is a function of x only. Then we can say these are the this equation is a standard form of linear differential equation with constant coefficient. What thing is important? This constant here, coefficient of dny upon dx raised to n is 1 is constant, and all other remaining constant, all other remaining coefficients. What are coefficients? p1 p2 up to pn all are constants, and right hand side is a function of x only. Then we can say that linear differential equation is a linear differential equation with constant coefficient. So capital X, right hand side nothing but capital X must be function of x only. So which answer is correct? Answer B is correct. Getting me? Solution is what? Function of x. See example number 2. If a linear differential equation with constant coefficient and RHS equal to 0 has a real root, m1 is repeated 3 times, then corresponding part of particular integral is. We have seen case number here. Which root we have given? We have given root is a real, and that real root is repeated 3 times. We have seen in case 2, If root m1 is repeated 2 times, that time complementary function is given by c1 plus c2x into e raised to m1x. Getting me? Here that real root is repeated 3 times. So corresponding part in a particular integral is what? You may say corresponding complementary function is what? c1 plus c2x plus c3x square into e raised to m1x. Suppose here we have given m root repeated 3 times. Suppose m1 is repeated 4 times. That time we have to write corresponding part of the particular integral. That time we will write c1 plus c2x plus c3x square plus c3x cube, okay, into e raised to m1x. So for this question, correct option is what? B option, this option, c1 plus c2x plus c3x square into e raised to m1x. See question number 3. If a linear differential equation with constant coefficient and a right hand side equal to 0 has imaginary roots alpha plus minus I beta repeated twice, means 2 times, then corresponding part of the particular integral is, okay, these are the 4 options. First option is what? See here, first option, e raised to alpha x c1 into c2 cos beta x plus c3 into c4 sin beta x. Option B, e raised to alpha x c1 plus c2 cos beta x plus c3 into c4 sin beta x. Option C, e raised to alpha x into bracket c1 plus c2x cos beta x plus c3 plus c4x sin beta x. Option 4, e raised to alpha x c1x plus c2x square cos beta x plus c3x plus c4x square into sin beta x. See, as we have seen, at right hand side equal to 0, you must remember one thing is that whenever right hand side is 0, there is no particular integral. We are dealing with only complementary function. Getting me? So here root is given imaginary. What are the root? Alpha plus minus I beta. These are the imaginary root. Alpha plus minus I beta. And that root repeated 2 times. So we have done in case number 2. If imaginary root is repeated 2 times, that time we have to write a complementary function as e raised to alpha x into bracket c1 plus c2x into c1 plus c2x into cos beta x plus c3 plus c4x into sin beta x. So option, which option is correct? C option is correct. Okay, second multiple choice question and third multiple choice question, these are this is related to the standard definition of complementary functions. Okay, these are belongs to the case number 2 and case number 4. Okay, these are the standard formula. Again, see, what is the answer for third question? C is the correct answer. See question number 4. 1 upon d minus a x is equal to, this is again a standard formula we have done in last lecture. What is the answer? 1 upon d minus a into x. These are the standard formula. 1 upon d minus a x is equal to what? E raised to x integration capital X into e raised to minus x dx. So answer for this question is what? E raised to x into integration x into e raised to minus x dx. Now whenever here plus sign, that time that means 1 upon d plus ax is nothing but this. Okay, if here plus sign, this answer is correct. Whenever here negative sign, that time C answer is correct. Now see question number 5. 1 upon d minus 3x is equal to, okay, here here is a small x because we have to use this formula. Here is a, here we have taken 3. Here is capital X, in place of capital X we have taken small x. So 1 upon d minus 3x is equal to, we have to use this formula. This formula we have to use. Okay, e raised to x integration capital X e raised to x dx. So a nothing but 3. and capital X nothing but a small x. Okay, so what do we get? E raised to 3x integration x into e raised to minus 3x dx. If we solve this integration, after solving integration, we get we get minus x by 3 minus 1 by 9 into e raised to minus 3x. Okay, here is a e raised to 3x. Now multiply e raised to 3x inside the bracket. E raised to 3x, e raised to minus 3x becomes cancel. We remains with minus x by 3 minus 1 by 9. So we get option D. Getting me? We have to use this formula. 1 upon d minus x is equal to e raised to x integration x into e raised to minus x dx. So capital X nothing but small x here, and a nothing but 3. Use this formula. Here we get e raised to 3x integration x e raised to minus 3x dx. Solve this integration. After solving this integration, we get e raised to minus 3x into bracket minus x by 3 minus 1 by 9. Multiply this bracket by e raised to 3x, we get minus x by 3 minus 1 by 9. We get this is the required answer. Now see question number 6. 1 upon d square x cube. Okay, these are the simple integration. D nothing but only d nothing but one time derivative, d square nothing but two time derivative, d cube nothing but three time derivative. In this way, similar way, 1 upon d nothing but one time integration, 1 upon d square nothing but two time integration, 1 upon d cube nothing but three time integration. Here is what? Here is 1 upon d square, so two time integration. Two time integration of which quantity? Here is what? X cube. So we have to integrate x cube. How many time? Two time. So first integration of x cube is what? X raised to 4 by 4. Again integrate, we get x raised to 5 by 4 into 5. So we get x raised to 5 by 20. So for question 6, correct answer is x raised to 5 by 20. Next, question number 7. 1 upon d square minus 4d plus 3 e raised to 2x is equal to, okay, we have to find a particular integral for this, and right hand side is what? E raised to 2x, and this belongs to the type number 1. Whenever right hand side is of the form e raised to x, that time we have to put d is equal to a. So here a is nothing but what? 2. Put in denominator d is equal to 2. We get 2 square minus 4 into 2 plus 3. 2 square nothing but 4 minus 8 plus 3. 4 minus 8 or nothing but minus 4 plus 3 minus 1. So we get here 1 upon minus 1. Denominator is not 0. So we get required particular integral. So 1 upon minus 1 into e raised to 2x. So we get minus e raised to 2x. So this is the answer. Okay, C option is correct. For question 8, see the particular integral of this is the linear differential equation with constant coefficient. Right hand side is e raised to 2x. We have to find solution, but here in this MCQs we have to find only particular integral. So there is no need to find a complementary function. We can find here directly particular integral. So particular integral, definition of particular integral: 1 upon f of d into capital X, 1 upon f of d nothing but what? D cube minus 3d square plus 4 into e raised to 2x. Whenever we put d is equal to 2, denominator becomes 0. That time we have to do what? We have to do take x on numerator and take derivative of denominator. Again put d is equal to, check whether denominator becomes 0 or not. If we get denominator becomes 0, that time again take numerator x square on numerator and take again derivative of denominator, and by using this process we get answer as a x square upon 6 into e raised to 2x. Now see problem number 9. Pi of d plus 1 cube y is equal to e raised to minus x is, okay. By definition of pi is equal to 1 upon f of d into x. F of d nothing but d plus 1 cube, and capital X nothing but e raised to minus x. So pi is what? 1 upon d plus 1 cube into e raised to minus x. Here a is minus 1. If we put d is equal to minus 1 in the denominator becomes 0. That time we have to use a previous procedure we have discussed. take x on numerator and take a derivative of denominator, again put d is equal to -1. If denominator becomes 0, take d square on denominator, x square on numerator, and take again derivative of denominator. By using this process, we get answer as x cube upon 3 factorial e raised to minus x. Okay, and last example, example number 10, the complete solution of d raised to 4 plus 6 d square plus 9y is equal to 0. Here right hand side is 0, so there is no particular integral, so complement function is a required complete solution because right hand side is 0, particular integral is 0. Okay, so we have to find a complement function. For that, auxiliary equation is what? D raised to 4 plus 6 d square plus 9. So root of these equations are plus minus root 3i plus minus root 3i. Roots are complex imaginary roots and roots are repeated. Alpha is 0, beta is root 3. So corresponding complete solution is what? C1 plus C2x cos root 3x plus C3 plus C4x sine root 3x. Okay. Okay. These are the three. These are the 10 multiple choice question for this lecture. Remaining MCQs we will discuss in the next lecture. Okay.